Good day, everyone. I will be looking at electronics, looking at the basics of electronics. So I want to discuss voltage, current, and resistance. I will try my possible best to cut out all those things we do in class where we have a lot of theoretical talk without having a very good understanding of the concept. So for us to understand electronics, we really have to know what voltage is, what current is, and what resistance is. Voltage is actually like a driving force of current. I think that is simple enough. Voltage is the driving force of current. Or what that would mean is, if there is no voltage, there will be no current. It's as simple as that. We need voltage to push current to move. I think that is simple enough. In school, you might see something like voltage or potential difference is the work done to move an electric charge between 2 points. But guys, let's just leave it at this definition, that we can see voltage as a force that pushes current or a force that drives current. Now, what about current? Current is actually the movement of electric charges. Yeah, current is the movement of electric charges. I had to use charges to give you an encompassing view of what current is. That's because many times people look at current as just the movement of electrons. Well, I submit to you that current actually goes beyond electron moving, because when we talk about charges, it is either we are looking at electrons are negatively charged, particles, it could be proton are positively charged particles. Sometimes we even talk of ions. Ions are also charged particles that can be positive or negative. Now, when you look at an electrolyte, for example, we have movement of ions, movement of electrons. When we look at a discharge tube, for example, we see that the charge carriers there are majorly electrons and ions. So that is why I restricted my definition of current to the movement of electric charges. Alright, now our voltage and current, these are the two major signals we discussed in physics. Now we can have an alternating voltage, we can have a direct voltage. It can be alternating or direct. That's it. Voltage can be alternating or direct. When we say a voltage is alternating, let me give you a practical explanation of that by just describing alternating sources. Well, your alternating sources will be your generator. Now, your generator, the voltage it provides for your home will be alternating voltage. Okay, your local power station. I had to use the word local power station. That's because in many countries of the world, we do have different power services and they have different names. Well, I can mention a couple of names, but I think generally I will just say your local power station. That would be okay. So your generator, your local power station. It will surprise you to know that your inverters also provide AC. Your inverters, they also provide AC. So these are AC sources. What about your DC sources? Your DC source will be your battery. A battery is majorly a DC source. It could be your solar cell. That's also another DC source. These are the two major DC sources we have. Well, if you know of more, you can add it up in the comment section, because I'm your colleague, I'm also learning. But I want to give you a very simple way of viewing these things. So your voltage can be alternating or your voltage can be direct. Your current can be alternating or your current can be direct. Your alternating voltage pushes alternating current and your direct voltage pushes direct current. I think that's simple enough. Okay? Now, for you to know that the voltage or signal we are referring to is alternating, you're going to see this symbol many times in your textbook. If it's going to be direct, you may see something like a dash with a dot. So this first one is alternating. Let me use A to represent that, and this other one is direct. Let me use D to represent that. Okay, let me just change my, okay, I think that's okay. Alternating, direct. I think that's clear. Very, very simple. So I can just draw a simple circuit where I have a battery, and I can just do something like this. Well, this circuit is very simple, but trust me, if you connect your power, if you connect a battery this way, it's going to be a disaster. That's because this wire, a conductor, offers some form of resistance, and that is where our resistance will be coming into the picture. The resistance offered by a wire is very, 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 very low. So if you connect your circuit like I showed you before, where you just connect the terminals of your battery and you link them up this way, what you get is a catastrophe, because the resistance is very, very small. Large current flows into your circuit and it makes your wire hot, it can burn you, and it can also destroy the battery. So in electronics, what we do is we have manufacturers that have made devices that have resistive properties, and these devices are called the resistors. Right? So this resistor could be represented like this. I believe the American like that symbol. Well, the British, the Englishmen, they love to use that box-like thing for a resistor. Well, if I use any of them, it will be because it's a matter of preference, right? So this is a resistor. So basically, a simple circuit, we have a battery, this is a DC source, a resistor, and perhaps your load. But for now, let me just leave it like this, where I have my V, my R. When I connect this circuit, then the voltage pushes current into the circuit and current starts moving. And in case you are asking for direction of current, well, when current moves from the positive down to the negative, we call that the conventional current flow. But actually, current actually moves from the negative terminal to the positive terminal. That is the actual current flow. It happens that in electronics or in physics, voltage, current, and resistance are related by a simple formula. Your V is equal to IR. If your since V is equal to R, this is called Ohm's law. It's called Ohm's law. Ohm's law propounded this some years ago, and this simple formula can be used to do quite a lot of calculations. Even some complex design can be broken down into V is equal to IR, where you can solve for your current, resistance, and voltage. Alright, so this will be it. It's now that you know, you can actually work with all of this. For you to know electronics, you need to know the voltage, you need to know what current is, and you need to know that there are components that offer resistance, and we can start from here. And in physics, we just said that V is equal to IR, and this is simply Ohm's law. And many complex circuits can be broken down to using just this simple formula. So for those of you that don't like the Thevenin, the Norton, the Kirchhoff's rule and all that, I think I just consoled you now. But as time proceeds, you may need to learn just a little of this or that. You may not need to learn all of those complex things that you did for you to have an understanding of what electronics is. I'm going to stop here, guys. I believe you enjoyed the video. If you don't like my video, please make a comment. I'm just coming up, growing and everything. I just feel I have some things to deliver to you, and let me start giving them to you. In the future, I'm going to make my presentation much more sophisticated than this. I'm using what is available now to me. Thank you very much, guys. Love you so much. Bye bye.